Hey guys, as you can see, I am wearing my shroud of sadness because rip my other video. I made a video like 2 days ago, and my awesome Guitar Hero microphone wasn't set up on my piece of garbage software. Which is, by the way, to the devs who make this, y'all are doing an amazing job. It's a user error. It's my own fault that I broke the thing. I had a dialog open and I closed it, and apparently the setting on that dialog was for which microphone to listen to while I'm recording a video. So I like royally busted it. Hold on, why on my pretty background thing not running? There's a name for this thing. Camera star somewhere. Look, Cloudy Master. That's the one. There we go. There's my awesome background. So, sorry guys. I'm still I'm hidden under my shroud of sadness. I'm just kidding. Let's get this garbage off. It's just my old sweater. It is a balmy 13 degrees Celsius in rainy Cape Town. Excuse me while I get a sip of my virtually transparent cup that matches my background color. You all don't know, but my green screen is actually just a blanket. It's a baby blanket that I got. So I spent like an hour on, I think it was on Saturday past, recording this amazing video for y'all. And while I was recording, I was live coding this thing, right? Like this, remember we were building this, and I spent like the last time I spent like a bunch of time explaining all this weird crap. And then the video I was busy making, I was like, okay, yeah, I'm gonna define some about dialogue. I edited resources, and I did like a bunch of stuff, and I made an on-timer function, and that on-timer function was just epic. And I did some debugging, and I did like a paint thing that was doing stuff, and I was like, yeah, and then let's clean up, we'll kill timer, and then delete this my paint stuff, and we did like a whole bunch of things, right? But it turns out that there was no audio. So like I can recap what's there, but I don't really feel like undoing and redoing it just for the sake of the video. So I do apologize. It's a sad banter. It's my sad face, but we can recap. Let's just go back and talk about. Let me think about it. Let me just take a sip from my transparent cup while I think about where I want to start off, where I want to go with this. Oh, I remember I started off my last video, my previous video, with just talking about scope, right? So in this language, you define scope as, here's this little box, and in this box is, like, I define variables and stuff, right? But from inside this box, I can see out. I can see all these variables and stuff. I can stick my hand out the box and grab things and use them and whatever, right? But no one can see into the box. It's a poor way of explaining, but that's kind of how scope is, right? If you look at these little braces, these braces in C++ are how you define the start and end of a scope. Let me just do an example. This defines an anonymous scope, int I equals 0. Oh, what did I do? I'm building it. While it builds equals, it's gonna fail. Int I equals 0, I plus equal 10, right? I plus equal 11. So here's something interesting that you'll see immediately. Let's just call it index, so it's a little bit easier to see what's going on, right? And then here we'll just call it index. So here I define, here's the start of a little box and the end of a little box. Inside that box, inside that scope, I define here as an int. Its name is index. Its value, initial value, is 0, so it populated with 0 initially, and then I add 10 to it. But now immediately after the box kind of closes off, and I start typing index, what's this? Index is undefined. But it's right there. I can see it. I can add to it there. Like, why is it undefined here? Like, what is this? So it turns out these little curly braces are kind of defining and saying, like, inside this little box, I can declare whatever I want, but outside, immediately after this, the scope ends, and any temporary variables that were created inside that scope, uh, they just get destroyed. They don't exist anymore, and you can no longer access them. And that makes sense. It's how scope works in these languages. I think Python has this concept of scope as well, which uses indentation as instead of these braces, it uses indentation to signify the beginning and end of a new scope. I think JavaScript successfully uses scope the same way. PHP also does this. PHP's got let's not talk about PHP. PHP's got weird scope rules. There were some like impossible things that I was doing in PHP that I was convinced like this shouldn't work, but it worked, so it made my life easier. So let's kind of just PHP the side. So yeah, so here's scope, right? So this is kind of scope, and here's the interesting thing: you can see the outside things inside the scope. But if you declare a scope in a scope, and in the nested, this is called a nested scope because it's nested inside this one. If you in this nested scope say index plus equals 20, when the scope ends, the value of index is going to be 30, right? So index is 0 plus 10 is 10 plus 20 is 30. So index is 30 here. So you can do like plus 39, index is 60. But if I do something like this, and then I try and say, well, not index plus equal to 2, all of a sudden not index is not available. I think you get how it works. Like the further in you go the braces, the more you can see out, but you can't see into those braces. You can only see out from within the braces. So you can see anything on a higher scope, or you can see the outer scope, but from outside it's difficult to see the inner scope, right? So this is just how that works. This is a very interesting quick example. It works like this with every type of variable. You can say char, and char equals like c, right? And you can say, because a char is just a value, c plus equal to 2, not c plus 2 plus equal to 2, no, not c and char. You can just add 2 to it because it's just a value, and then you can say and char plus equal to 3, and then outside there you can no longer access and char because it doesn't exist here. See, red. This red means error. So this is how scope works, and the reason I wanted to touch on scope is because I remember in video 1 of this tutorial C++, we're going to make that blocky game thing in C++. In video 1, I touched on how this message bump works and how all these things work, and I didn't really get to define scope. I didn't really get to explain exactly how it works. So oh, there's something in my eye. That's so unpleasant. Sorry, I think it's an eyelash. It has failed me. Its one job is to keep things out of my eye, but the majority of things I find in my eye are eyelashes. It literally exists on my face to do one thing. You had one job. So let's just fly through this. I want to fly through this in like 2 minutes if possible, or even less. All of these things exist in a global scope, right? The global scope means they are visible everywhere inside this compilation unit. A compilation unit in C++ is defined as a file. In this case it's a C++ file. Header files can be shared compilation units, so if you include this header file somewhere else, this thing would be accessible somewhere else, the same way we have now defined and said I am interested in including the contents of this header file. The preprocessor in C++ goes through and concatenates a bunch of files. So where you've got a file, you've included it in your project somewhere, you've said, hey, I've got this file in here, it is boom, that file name. So now the compilation system knows that there is this file that's part of this project. When it compiles, it knows to look at this file as part of the compilation step. The preprocessor gathers all these hash include things. Wherever it encounters a hash include, it goes inside, opens up this file here, rips this contents out, and pastes it as if all of that was sitting right here. So the hash include essentially says copy paste the contents of that file here. This is done recursively. So when it reads this thing, it says, oh, it includes this other file. Then it goes inside this other file which exists here and says, oh, let me just rip the contents of this file, paste it in here, over this hash include statement. So there's no hash include, it's just the contents of this file gets pasted in there, and then all of this gets pasted in here recursively. So each compilation unit is defined as a header file or a C++ file. When you speak about global scope, the scope is defined as there's everything, which is all the operating system stuff, and then all the language specific features, like if you this language has a concept of a variable type and a variable name, right? These types are available everywhere. These names you can just type anywhere, assign it to this type, but these types are available everywhere. So these types are global. Preprocessor statements are global. Hash defined are kind of global, but only global if you put them in here and then use these names. These purple things are called names, the token names. These purple things, they can be used wherever you have included the things. So if I say hash define blah, wherever I have included this file that has that thing in it, I can say var I equal blah. I can just do that because blah does not evaluate, not var. This is int I equals blah. If I just define blah at not a semicolon, 0, I can now use blah because I've included the file that has blah in it. So namespace are a very neat way of defining scope. You can name a scope, and naming a scope is called a namespace. Another way of naming a scope is by calling it a struct and giving it a name, and that is a special namespace. Classes are also special namespaces. Functions are incredibly special namespaces which generate pointers for you to the function by just calling the name. So there's a whole lot of stuff. There's special rules applied to functions in terms of accessibility. There's like private, protected, whatever thing going on there. I just want to undo this. So let's just say that, you know, there's this global namespace that's like, if you declare this thing at the top level in your file, it is accessible everywhere inside this compilation unit. If you define things here like this, it is accessible everywhere where that compilation unit is included. So if I define, yes, this namespace game, and inside, yes, this struct my paint stuff, I can then go and say blah doesn't exist. I can then go and say that namespace name dereference operator or accessor operator colon is an accessor or dereference operator, something in that namespace, and then I can declare an instance of it and use it as if it just lived kind of here, right? So the scope in like 4 minutes, even though I wanted 2 minutes, 4 minutes. With that said, we now have all these functions. For declared in this for declaration is just telling the compiler, here is a function name, it takes these parameters, and this is the return type, and it has no body. That semicolon means that's the end of my declaration. The reason it's called a for declaration is because you declare this up here, up front, and then later down the line, right, you actually say, hey, here's this exact same function name return type, but the big difference is there's not a semicolon there. There's a function body that fleshes out and aside. The compiler just looks at it and says, hey, here's this thing I saw earlier. Whatever this is, replace it wherever you encounter this name, replace it with a pointer to that function, right? That's all that does. It's kind of like preprocessor, but not preprocessor. This is compilation step. this gives you, I've seen people do hash defines to define these function names and things. I don't want to get into that. That's a poor practice. You for declare these things so that when you access them here, the compiler knows there is this function, it returns this type, it takes these parameters, it's going to do something. But because I haven't encountered it yet, it would throw an error if you didn't for declare and tell the compiler, hey, here's something like this coming up. Otherwise you'd have to go and declare your functions all in order. The only time this doesn't matter is if you've got a class. If you your class you define in a header file, you define the class layout and structure, and those are for declarations, which then tells the compiler, hey, this class has these functions in there, so whenever you encounter these functions somewhere along the lines, this person is going to define the function body. So it's the same, it's as if you did this in here. It's like another way of doing it without having to do a class, right? So in the last video I did this. I made a namespace, called it game, because stuff relating to the game is going to go in this namespace. I created the structure, my paint stuff, because I wanted to paint things. I said I need to paint some stuff on the screen. I said, well, I'll create a structure that encapsulates all this information about the stuff I want to paint. What will I call it? My paint stuff. I'm so sad that I couldn't salvage that video. There's just zero audio in it. It would have been so nice, because there's like a whole long little bit I did about painted black. I had a bitmap and I wanted to paint it black, so I called it painted black. This my paint stuff just has two variables, I and x. I pass in two values, and I initialize I and x with those two values, and then paint the black I set to true, and that is just a structure that has three values in it, two ints and one bool. Over here I declare here's game my paint stuff with some values 1 2 3 4 4 3 2 1. This boolean value was it's set to true by default. Here we actually got into a little bit where we said set timer for this global handle to the window. It expects a uint pointer, unsigned int pointer, and you can just put anything in there that can fit into an unsigned int pointer. Your resolution of your timer is 33 milliseconds, and your procedure that gets called whenever this timer would have fired is this onTimer function, which is a timer proc. This onTimer function is again for declared here. It takes a handle to a window, which is the handle to the window that you've passed in. It takes a uint. I don't actually know what that uint is, but it takes a uint pointer, which is this pointer thing you declare here, right? And it has a d word that goes in. Again, I have no idea what those two values are, but what I do know is that this uint pointer parameter can be used. Where you see this uint pointer, it can be used. So whatever is passed in here is whatever you pass in here, and I'm passing a pointer to this my paint stuff thing that I'm declaring here. So we came up with this 33 milliseconds because we went and did we said 1 second consists of 1000 milliseconds. So you take 1000, why can't I type that, 1000 milliseconds, and I want to divide that by however many FPS or frames per second I'd like to draw. So if I want to draw 30 frames per second, if I want to know how many milliseconds that is, I'll take my 1000 milliseconds, which represents my second, I'll divide it by my 30 frames per second. Boom, 33.333 recurring, right? So that 33 milliseconds, I just put it there because you can't put, it doesn't care about deciseconds, it doesn't care about it's an integer value, right? The set timer function expects a resolution in unsigned integer. So this function does one of two things. If you don't specify a timer proc, then it will pass a WM timer message into your window procedure. But if you do specify a timer procedure, then you don't have to handle that WM timer message. It will instead, you can just say, well, call this function for me every 33 milliseconds or every however many milliseconds. That's exactly what we did. We said, hey, here's a function we want to call. That function is we for declared, but this function knows that it is being passed this MyPaint stuff thing. So you can, because you don't want to declare this MyPaint stuff in the global scope, you can pass it out of the scope by passing it in here. Windows is very nice. It just takes that pointer, because this thing, when you say new, this thing goes to walk on the heap, takes little walkies and says, hey, I need this much space. The heap says, hey, yes, you want the space, here's the space, right? And then it just plops us down there and says, blah. There you go. There's this thing in this space, but now no one else knows where it is, because there's only one place where the pointer value is returned to. Wherever you set new returns a pointer value. It says void star here, but it's typed to whatever you stick on the left side of new. It's automatically cast to the same thing. It's actually automatically cast to the same thing as what you stick on the right side of new. So when you say new something, that new operator returns a pointer to this something, right? So new is usually just defined as void star. You get a new MyPaint stuff thing, because that's what you put on the right hand side. You get a new pointer to a MyPaint stuff thing, and no one else has access to this pointer. So there's this thing in the heap that no one else can access. You can't clean it up. So we keep that pointer, we pass it into this function. This function accepts this pointer, casts this uint ptr garbage back into the correct type, and now we can use this thing and we can get at these values inside of it, right? We can get at these values inside of it. So we said, here's this MyPaint stuff. We set the timer, we process messages. Once the message pump exits, once this message loop exits, because you get a close message handler. That close message handler triggers a WM close. A WM close causes by the default window proc a WM close message. If you don't handle it yourself and the default window proc handles it, then the WM close causes a WM destroy message to be sent to your window. And if you care about being able to close your window, you would handle that WM destroy message. Inside the WM destroy message, we post a quit message, which causes this get message to return false, right? Once this returns false, we break out of this while loop, and then we know we're not going to ever be able to paint, because we're not processing messages anymore. So what do? We kill this timer, right, that we created in this function, in this fashion, and then we delete whatever thing we were trying to use in that function. In this instance, it's this MPS, and this MPS we can't delete from anywhere else because it is declared in the scope. No one else can see it, only we can see it. Great. So that kind of sorts that out. There was a lot more I was saying about scope and how the message pump works, but let me just spend the next 2 minutes going over this. So you got this crap in the global scope, and you tell Windows, hey Windows, create me a window, register this class name, create me a window, and in this window I want to handle these messages, because we tell Windows this Windows message loop thing that we care about is this thing called windproc. And this windproc is just a callback function that Windows calls from itself. It says, hey, when I have messages to pass to this class of Windows, there's a procedure I can call to say, hey, here's this message thing. But that's not exactly how that works, because Windows says, well, I don't know if that thing is busy or not. So I can queue up these messages for this window class, right? So it creates like this FIFO buffer, a queue. It's just a long queue, and it says, okay, internally Windows maintains this queue. It says, okay, you've got this mouse move messages, you've got a click message, you've got a mouse down and a mouse up, and you've got a double click message, and blah blah. So you get a ton of messages, right? How do you handle those messages? This is how we handle those messages. We get those messages off the pump into this value, right? And then we try and translate the accelerators, which returns false when it's done. It returns 0 to indicate success. So you could say if error success equals translate accelerate, it does the same thing. If that equals translate accelerate, I just like this much more terse expression, that just returns 0 to indicate success. You translate this message, and then you dispatch message. You can actually create a message. This is the nice thing. You can create your own messages somewhere and dispatch them to your own message pump. This dispatch message tells Windows, hey, call my window proc, because you don't have to define it in this file. We just define it in this file because convenience, right? You tell Windows, hey, call my window proc, and it will know it's calling it for your window because you created this window with that class name. It knows it's for this window. It tells you the message, and it passes two parameters in, a W param and an L param, and these params are used in different instances. If you handling a command message, this W param, the lower of it, the lower 16 bits of it, is it contains the command ID, which is the accelerator, or a menu item ID that tells you, hey, someone's clicking on menu things. There are other things this thing can contain. If you're handling a timer message, that thing will contain that uint value that you stuck in your timer. It will contain your timer ID. So it's like this whole bunch of stuff that these things can contain. But what we need to care about here is that this thing you don't call directly. Windows calls it for you, and it populates whatever's missing here. Right. So that kind of explains why we care about passing this thing into Windows and saying, hey, yeah, you do it. Because this dispatch message is actually what pushes the message out of your own hands into your WinProc. Right. So now I got a WinProc. So now in this WinProc, I didn't feel like doing a bunch of stuff. I said, hey, you know, when we're painting, just create this paint struct, get this DC out of it, begin paint, end paint. It's a very neat way of saying, you know, I don't actually want to draw anything, but I don't want this paint struct to go to waste. So yeah, you know, get a DC out in the paint. So let's get to this magical on timer thing. Yeah, I've set a timer, and this timer calls this timer proc on timer thing, this function that we've forward declared, and then later on given a body here. Every 33 milliseconds, I cast out this value into an whatever the type is. This is my paint stuff. I populate this rect with the client rect of the window. So whichever is outside of this menu thing is non-client area. This menu bars and things are non-client area. The title bar here on top that contains the thing name is non-client area. Side toolbars, status bar, all this rubbish, non-client area. This inner piece here, which in this instance is filled with whatever garbage and code, is the client area. So we call it this dark red piece is the client area, and this not so dark. Oh, what was that? Huh. I didn't know you could just double click it there. This not so dark piece is the non-client area, right? We say get me this rectangle, the inner bound, so not the thick frame, not the caption, not the sys menu, not the buttons, not the status bar, blah blah blah, not the scroll bar, whatever. Get me that piece, this inside square. Get me a DC to the window or device context, and then fill this rect with, if I'm painting it black, paint it with a black brush, otherwise a gray brush, and then release the DC so that I don't occupy all the handles in the system, and then flip this painted black to not painted black. So if it started out as true and you say it equals not true, it becomes false. And if it comes in here again and it says, hey, painted black equals not painted black, if it was false, it becomes true because not false is true. So then you store, each time you store here, this value in here, it becomes the opposite of what it was, right? And then once you do all these things, magically you get a thing that is black or gray, right? Each flame it will flicker black or gray. Flashing thing warning, so people who have epilepsy, don't look. There we go. So here oh shoot, what did I do? Here we've got a thing that is flashing really quickly. We can see that kind of does, well, on my screen that kind of does look like 30 FPS. It's not open. I don't like looking at it. It's unpleasant to look at. So we have a drawing loop. Remember how in like let me just stop this thing. Remember how in the JavaScript tutorial series, it's like on day 1 we had the drawing loop. In C++ is a little bit more involved. If you're using GDI Win32, you have to kind of work with Windows and tell Windows like, hey, I'd like this thing to kind of do this stuff. But now we've got this thing. It flashes, it draws on the window, it does all these amazing things, but this doesn't help us. And it doesn't help us because this is not double buffered. I'll talk about double buffering now. In JavaScript, everything is just always double buffered. Let me just comment this out and kind of show you what happens. It now won't flash anymore. I think it'll just use the black brush by default. If you are drawing something onto the screen, right? Well, actually, I don't think we're gonna need it here. We're drawing everything each frame. Let's do this. I can actually do this like very easily. Get client rect int of height equals rect.bottom equals rect.bottom divided by 2 rect.bottom equals old height. And then in this instance, I just want to say paint me a gray brush. Let's try that. If you don't double buffer, then every time something changes on the screen, it will flicker. It's one of those things. Oh shoot. Rect.top equals rect.bottom. Sorry, I moved that thing's bottom around and didn't move the thing's top around. So you got something it's half gray, half black. Let's see if we can get, there we go. There you can clearly see the flicker. If you don't double buffer, this is what happens, because you make a change and Windows says, hey, that thing's client area is no longer valid. And with that invalidated client area, Windows says, hey, I need to send a WM erase background message. That WM erase background message is actually, why don't we just handle that? Why don't we just handle that? The WM erase background basically tells Windows, hey, you know, should you return non-zero if you handle this message? It basically tells Windows, hey, you know, fill this thing in with whatever the background color was set to, and if you recall correctly, we set this background color to black brush, right? H brush background is black brush. Fill in with the background color, and then once the background is filled in, immediately try and do a paint, right? In our paint, we don't actually do anything. We're not using the paint struct for anything, so the paint basically just does nothing. But then eventually our timer function gets called, and our timer function says, hey, I need to fill this window in with like a bunch of different colors, right? So if we tell Windows, okay, ignore the WM erase background message, we're not going to erase the background in this instance, maybe it'll be better. Let's see. Yeah, see, much better. Don't need to double buffer, much better. So basically what we've done here is, when Windows tells us, Windows sends this WM erase background message to us, but if we don't handle it here and return to Windows a 1 that says, hey, I actually handled this for you, then we fall through in handling this message. We fall through into the default case, and the default case is def window proc, and the def window proc erases the background. It actually takes that thing and says, I'm going to smack this background brush onto your client area. There's nothing you can do about it. But hey, this is what we can do about it. We can tell Windows, it's cool, it's cool. I got this. Right. I erased the background. We didn't actually erase the background. You can see we're not actually doing anything, but we can tell Windows we did. This is how you tell Windows. Again, WM paint, same thing. You know, if you don't do this, Windows tries to paint your area, client area, with whatever thing it thinks it wants to paint. But if you handle it, you can say, well, you know, I got this. I began and ended the paint on my own. You don't really need to handle this, but by default we just handle it, because why not, right? The erase background message is actually the one you should care about. This is the nightmare that traps people. The first time they build things in Windows and they do a resize, they freaking lose their minds, because something now clearly isn't right, and it spends them hours on Stack Overflow trying to understand it. This is how you handle it. You literally just say, I'll handle this thing, return 1, I handled it. But you don't actually do anything, especially if your stuff is on a timer. If it's not on a timer, you might want to prep by erasing the background and then painting immediately over it. But my best bet is don't do it. Just paint everything, each frame. It is wasteful. It slows your system down a little bit, but it's so much easier to just to paint everything each frame than to struggle, right? So now that we have a drawing loop, and the drawing loop does it still does the thing. If I do this, you can see it's still doing the thing. I just commented out this logic that makes it flip and update, but it's still doing the thing. Now that we have a drawing loop, we can say like, hey, you see the piece that needs to be painted does the thing. Let's see, not so bad. Not ideal, but not bad. So we have our drawing loop now, and we have a structure inside this drawing loop that we can use to store the state of what we want to draw. This is my paint stuff, and in my paint stuff I would like to draw a, what was the first thing we did the last time? We tried to draw a paddle and we tried to draw a ball, right? So the paddle, we know that the paddle would sit somewhere along the bottom of the screen. So inside this my paint stuff, we get the client rect, right? And then we want my paint stuff to update based on this rectangle. We don't actually have this function, but we will. Once we've updated everything, we want to say, hey, my paint stuff draw, and for draw I would like to pass in this HTC that I get here. So I want to grab this HTC, and then I want to release this HTC, right? So why don't I do this update and draw step in 1? Seeing as how this is not a multi-thread application, everything happens in sequence anyways. Why don't I do this update and draw in 1? I kind of want to separate out the logic, internally, mentally. I want to separate out the logic of move things around from the logic of draw things. But in this instance, since we want to save a little bit of time, let's just do draw everything into this rect with this HTC. Let's just do that, right? We can just call this update and draw, right? Let's do that. That's much better. Update and draw takes a pointer to a rectangle and a handle to a device context, and all that stuff is going to go inside this thing. So inside my paint stuff, we now have a void update and draw, LP rect and HTC, and this update and draw now does whatever this thing was doing. Wherever it used to be just a straight dot dereference, it is now a pointer dereference, which is an arrow operation. It will DC HTC rect get stuff object. It's literally the same thing. It's easier to pass a rectangle by pointer or by reference. I could just do it by reference. There's nothing stopping me. So yeah, we don't dereference NPS painter black. We just say painter black, and we pull this out and say you are not who you think you are. And I did the silliest thing. I just dereferenced it as if I'm outside this class. This class is all inside. No, don't help me. Do the thing. Okay, great. So we've just taken all that logic and we've stuck it inside of this my paint stuff, because my paint stuff is where I want to paint stuff, right? Inside here I want to update and draw, and it will know that there's this paddle thing. I think for this video, given that we don't have that much time, I want to just kind of make sure that I draw the paddle first, and then maybe the next video and the next video and the next video we'll draw a ball and we'll do whatever. So given that there's this my paint stuff, and this my paint stuff responds to things that we don't know about here, right? I don't think it's valid to try and do anything special in here, right? We also don't have an I and X. So what do we need for a paddle? We need a paddle thing. We need a way of saying like, hey, I've placed this paddle here. And I think initially I want to know what is the width of this window that I'm going to make, because before you resize, I'm just going to take this weird comments of automatically generated comments. What is the width and the height of this window? Oh, x, y is 100, 100, and the width and the height is 400, 400. I would like to kind of define that. Hash define when width is, I want to give the 640 hash define when height is 480 pixels. Not really 480 pixels, but I want to use these values as my something, and I'll tell you why now. I want to replace that. I want to pass it into my paint stuff as a width and a height, right? And then we'll keep updating something as we go along. So I want to be able to say these things are all the same value. Where did I put that? How did I lose it? Whew, excuse my stress. Also, I'm not a fan of this I'm not a fan of that 80 character limit. This is all conceptually one function called one line. I want to just say, do it in one line. There's no reason to split it over like that. There's also no reason for this to be on its own line. I want that to look like that. Actually, I want all of these things to be tabs. Tabify selected lines. Yeah, now they look right. Now that looks much better. The formatting is something I don't really do on air because it takes super long, but it just bugs me. Like it completely bugs me because it just doesn't look right. It freaks me out. I can see myself going through this a bit later. Let's just take this comment out. We know what this is. We've spoken about this like for 2 videos now. We know exactly what that's doing. I can see myself going through this later and just having a lovely time. Huh. Edit. Tabify selected line. Why is it suddenly not tabified? Are they these? Why are these not being tabified? Edit. Tabify selected line. Like what the flip? Oh. Do you know why that doesn't work? Wherever it finds 4 spaces, it will happily convert, but those were 3 spaces. So it says, I don't know what to do with this. So now we've got a win width and a win height that we've created, and I've put this win width and this win height in here, and I now want this thing to have a int width and an int height, and then my width is this width and my height is this height. And I'll tell you why I want the int width and a int height, so that I can set the paddle positions, right? So paddle x, paddle y, paddle width, paddle height. Oh no, underscore height. And then we'll have the same for the ball. Int ball x, ball y, ball width, ball height. These are different ways I can declare a structural union or a data type that represents this thing, but whatever. I just gotta, I should call this window width and window height, but let's just call it width height. So what can I define here? What can we define here in this instance? What can we say? Oh, we can say, well, no matter what the size of the screen, the paddle width is some function of the screen size, right? I'm just thinking we're going to do this all the time. Void update. And I want this. I want to make some kind of distinction between public, private, etc. I want to define here as an interface. This is private variables, and then the public variables, and then this internal updates thing just goes inside the private section, right? Because this update in draw exists externally, you call this update in draw from outside. Externally, you call this constructor, and this constructor does things, but internally you call this update value, right? And you call this update value after you've managed to set the width and the height. So update in draw, width equals the max of 1 pixel. Actually no, I want to say that I'll go as low as 320, and if this rectangle is actually bigger than 320 pixels wide, and then I want to use whatever the rectangle's width is, and to get the width of the rectangle you do rect dot right minus rect dot left, right? And that's how you get the maximum of those values. And then height equals the max of 240 and rect dot bottom minus rect dot top. Why is min and max not defined? Is this Windows not like me? What's going on? And then I want to say update, right? Get the width and height and then update. So this width here and this height here is just whatever they passed in here. So when we construct this thing, do I want to do that? Do I want to say the width is yes? So if someone constructs a stupidly small window, then tough cakes, right? Width and height, and then this is this width and this height. There we go. That should become what variables now. So 20 to 40. Okay, great. So now we grab those things, we do the thing, we say update, and our update actually says, hey, my paddle height is, and now we can work according to these, right? If the width of this, well, actually the paddle height, let's do the paddle width first. If the width of the screen is 320 pixels wide, then the paddle needs to be some appreciative value of that. It can't be a quarter of the screen, but it can be an eighth of the screen. So 320 over 8 is a safe bet. So the paddle width is actually just a static cost to an int width divided by 8, and the paddle height equals static cost to an int height divided by something. So if it's 240, I want it to be like 10 pixels. So what is 240? How do you divide it to get this? 20. 240 divided by 20 is, no, 240 divided by 24 is 10. So 24. See, easy peasy. This will roughly keep the same size. Roughly. There's an easier way. You can actually work in percentages. You can say that my width is actually a function of the percentage of the screen size. I feel like that is a better way of doing it, especially given that we're working according to a fixed size. Initially, we know that it's not going to go smaller than this. We can actually go according to percentage. So what percentage is 20 pixels of 320? So well, to get that, you obviously divide by 3 point someone, right? To get 20 times 20 divided by 3.2. 3.2 is 6.25%. So I want to say that my paddle width is 6.25%. 6. Huh. Let's see how the flip do you do this. Is 6.25 f times width divided by 100 f, and then you static cast that to a float width divided by 2.0 f times 6.25%, and then we do the same. We say, what is of 240? What is this? Is just it can't be 10%. It's going to be huge. It should be like 6% would be the easier way. So again, you do 6.0 f times static cost float height divided by 100.0 f. That gives you a percentage times 6%, right? Is that right though? And initially, let's do so with this 2 foot. Let's just work it through. I feel like that's not right. So you do with these 320 pixels divided by 100, 3.2 times 6.25 equals 20. Okay, so it is right there. So that's now 20 pixels wide, and let's see, it should be 10 pixels high. So height is 240 pixels divided by 100. That gives you percentage. It's 2.4 pixels. Is 1% of the screen of 240 pixels height is 2.4 pixels. Times 6% gives you 14.4. It's a little bit on the high side. 2.4 times 5% gives you 12. 2.4 times 4% gives you 9.6. Close enough. So 4%. So I can do seal. That seal is, did I just define it wrong? No, seal is, that's the value for seal if. Screw it, I'll just static cast that whole thing to an int. I don't need that extra brackets. So I'll just do 4.2 times 2.4 equals 10.0. Yeah, it'll round down. So if I just do 4.2 and then static cast, oh lovely, that to an int, I'll get my values up. So now that I've got my paddle width and my paddle height, right, I can actually start saying here's an interesting concept. Now that I've got this, here's an interesting concept. If you are building a game like this, you shouldn't allow resolution changes, and this is why you'll see in a lot of old school demo effect games, they go full screen. They immediately choose the resolution they want, and then they run in that resolution. They don't allow it to change the size of the screen afterwards. We also shouldn't allow that, which means that this update and draw function shouldn't actually take this rectangle, but I'll tell you why it takes this rectangle. Because this my paint stuff should composition a bitmap for itself. I didn't want to do a bitmap like on tutorial 2. And I'll tell you why. If you have put this paddle somewhere on the screen, right, paddle X, you say my width is whatever these values are. Actually, let's just take this out. Let's just ignore that for now. Let's try to not update. let's do that. This initial update. So this initial update would just be, yeah, we set up a bunch of stuff, right? So there's no such thing as this initial update. So there we go. And this is still this width, and this is still this height. This is actually a good thing to catch right now. Once you've placed these things, right? So now you say my pedal x equals this width shift 1, which is actually divided by 2 minus pedal width shift 1, and in the pedal y equals like whatever, right? Shoot, what would the pedal y be? Oh, this height minus pedal height times 2, right? It's a shortcut to say times 2 times 1, whatever. Once you've defined these pedals, you've now got a position of this thing. So let's just think it through. You've said this thing is here on the screen, well, slightly off the center, and now you resize the screen. What happens to that thing's position? You have to take that position and then scale it by some value, and then seamlessly scale everything else by some value. And that is it's not an expensive operation on the CPU. Modern CPUs can handle billions of operations. It is an expensive operation in code, in terms of the amount of code you have to write and maintain and debug. It's an expensive operation in terms of just conceptually how will you handle that. Like, I don't want to have to keep track of what scale I'm operating at. I want to be able to say, you know, I'm running everything assuming it's a 320 by 240 screen, and here's a couple of fixed widths and heights, and the user hit the left input, which is either a mouse movement or a left arrow key, and I want to move the pedal to the left or to the right. I don't want to have to keep track of that. When I draw this pedal, I want to scale it by X amount. I want to do that once, and then that's it, because I want to be able to say, you know, fiddle with these percentages, but then after that leave that alone. So for now we'll do this, and then we'll create we'll take this out. I know for a fact I'm not gonna do all that weird calculation thing. So let's just do that. I want to update and draw. I want to full rect this rect on this HTC. I get stock object black brush. Alright, and now I want to declare my own rectangle, right? So I want to do rect r equals left rect r is, just want to see the order of the params. Doesn't tell you the order of the params. Let's just do 12. Order is left top right bottom, right? Left top right bottom. Up need a file. So left is pedal x, top is pedal y. Pedal y. Why am I typing? No, don't do that. I'm trying to get the arrow keys. Pedal x, pedal y. And then the right of this rectangle is pedal x plus pedal width, and then the bottom of this rectangle is pedal y plus pedal height, right? So that gives us a rectangle, and then I want a full rect on the HTC R. Actually it's address of R, and then I'll get stock object gray brush. No, isn't there a stock object red brush? Please tell me there's a stock object red brush. Please, no. Oh, why isn't there stock object red brush? White, light gray, gray, dark gray, black, null, hollow, white, gray. Windows, as much as I love you, You don't love me back. Why isn't there a red brush? Why isn't it like, you know, in JavaScript you've got like a bunch of colors predefined on a context. You can just say context set full color like blue. Why don't we have like blue here? I'll just do a light gray brush. Screw it. It's just a contrast to show that here is a thing that's not like the rest. That's all. It's just to show that one of these things is not like the other. Also just want to fix this madness. Okay, so I should get a rectangle on the screen that is sitting at the bottom somewhere close to the middle, like centered on the screen. I'm getting something. This is not a good start for us conceptually, so let's see what's going on here. Paddle X, paddle Y, X, Y, and then paddle X plus width and paddle Y plus height. So we filled the black brush and now we're trying to fill the rect on the HTC get stock object light gray brush. And this should be getting, yeah, it's getting cool. So paddle X is 300, paddle Y is 440, paddle X plus width is 40 and height is 20. Could it be? Here's something just conceptually for you to mull over. Could it be that because I said 240 and I didn't include this, that paddle is actually sitting over here? Yep, there we go. I didn't include this height when I did this calculation, so there we go. Okay, great. I think I'll stop there for now. We have a paddle, but I think next time we come through to this, I want it. Oh, I've got a pretty hand cursor. Next time we come through here, I want to make this paddle move, and I want to make the screen. I want this to do something, right? Can I do it in 5 minutes, guys? Just bear with me. I want to not struggle like this, right? So let's do this. We're going to double buffer this thing, but not because we want to paint it in a certain way, but because I want to be able to maintain the screen size however I want it. So the first thing you need to be able to double buffer is you need to create a bitmap. To create a bitmap, you need to first make it compatible with the DC. To get your hands on a DC, you can copy it off a window, but once you copy it off the window, you have to release it again onto the window. But if you copy a DC off the window, create a compatible DC, you've then got your own DC, then you release the original DC, then you've got a DC against which you can go and create a bitmap. Right, so with that in mind, to get the handle to the DC initially, what I need to do is I need to have a handle to the window. Right, so then internally this my paint stuff thing can do its own like weird nonsense, right? But all I need then is a handle to the window. So inside this my paint stuff, it takes an H-wind, right? And then internally, this thing doesn't actually need a handle to a window. It needs a handle to a bitmap. And so I declare handle to a bitmap, so beam. And it needs a handle to a DC, which we just call DC. I think we'll just call it DC. Yes, call it DC. So you got a HDC, DC, and H bitmap. Here's the magic. Now that I've got a copy of this window, right? I can say HTC equals get DC H-wind. Get the DC of that window, device context. And then obviously before I do anything else, I want to do release DC of that H window and that HDC handle that I just acquired. So now I know I've acquired a resource, I've released the resource. This is just how Windows works. Or used to work. You can just request that handle, it makes a copy of the handle and returns it to you. It doesn't actually lock that handle in, like, reduce system resources. You can do this safely without doing release DC, but the correct way of doing it is acquire a handle, release a handle, right? Now that I've got that thing, I can say I want my DC is create a compatible DC with my DC must be compatible with the window DC that I just created. Right now I've got a window DC. I also, just by the way, I want to now create a destructor, and that destructor is public. Inside here I want to delete DC, right, because I've now created a compatible DC and I need to delete that DC. I also want to say that my bitmap equals create compatible bitmap, and I'm so sorry, that bitmap needs to be compatible to the DC I just created, which is also compatible to the DC I pulled off the window. Okay, compatible bitmap, DC, and then a width and a height. Internally I want this thing's width and height to just always be 320 by 240, no matter what the width and height of the window is. So I no longer want to pass the width and height in from outside, right? My paint stuff is smart enough to know its own width and height is going to be whatever I want it to be. So conceptually, this doesn't actually need to be a 320 by 240, which means that it doesn't actually matter what I make this, right? Because I'm not repeating this variable anyway. It will just always be whatever internally this thing knows it's going to render. So it can just be const int width equals 320 and const int height equals to 40. You'll see this beauty now. So this doesn't need to be initialized anymore. It's const. Yep. So now we can say this thing is a percentage of this and a percentage of that and blah blah blah. I no longer need to dereference this width and this height because there's no conflicting named variables in the scope. So it can just be width and height. And now I've got a compatible DC and I can say width and height. So now compatible DC, and I create a compatible bitmap, and the bitmap's width and height is W and H, right? So now I've got a bitmap. Right, now I release that DC. I don't care about the DC. Let's just check the parameters. Just HDC CXC1. Now I created this bitmap. Here's the kicker. To get this bitmap to be inside this DC thing that we created, we need to say select object into this DC. To our DC, our bitmap. Select object actually returns you an object. It returns you the default object that was in there. So we know that this thing is a bitmap type, but you don't need to do that. You can say h handle to a generic GDI object, old BMP, right? And now you set this old BMP equals select my new bitmap into the DC, which gets you the old bitmap out. We store that old bitmap because we want to say, okay, we want to deselect our bitmap off this DC. To deselect it, you actually just select something into it. So if you've got a DC and it's got this slot that's occupied of this type of thing, to get that thing out of that slot, you select the default back into it, right? Which pushes that out. Just put the salt side in there, which pushes that out. So now this default, this DC goes back to kind of its default state because it's now got a handle inside that is back onto its default state, and you've got this free handle that you can now delete, right? So let's delete that free handle. So now we've select object into my DC, that old bitmap thing, right? And now my new bitmap is just sitting inside this handle. It's not sitting in any DC, but because I now have none of my own resources selected into the DC, I can delete the DC, and I can also delete object my bitmap that I created. So now I've created a compatible DC and a compatible bitmap, and I've selected something into it, which has knocked something out of it. Now I knock my stuff out of it by selecting that old knocked out thing into this DC. And now I can safely delete the DC and delete this object that we created. So now there's no leaks in the section of code, right? There should be no leaks in the section of code. This is how the Win32 API works. You have to like keep track that there's these slots. If you put a brush in, it gets you out a brush, the old handle to the default brush it was selected. So to get your brush out, because you can't truly destroy the DC without first taking, you can't truly destroy your bitmap if it's selected into a DC. If you try and destroy the DC while your stuff selected into, if you try and destroy the bitmap while it's selected into a DC, it becomes like a leaked handle, right? So you gotta put stuff in and take stuff out in the same order. We can do utility structs for this, but if you really understand the concept, you can just do that and make sure you go in the backwards in the same order. Same thing. No big difference. Let's just kind of power through, because I'm running this into like an hour video again, which I don't want. Const width, const height, paddle x, paddle y, got a DC, compatible DC. I gotta select object, old DC, old bitmap. Now I got a thing with a bitmap in it, and I want to update and throw onto this HDC. So what I want to do is I want to fill the rect. My rect equals 0 width height, and this is the rectangle that represents my internal area, right? So I want to fill this rect, my rect, right? I'll tell you why, with a black brush. And now I want to draw a paddle edge, paddle y, paddle width, paddle height onto my DC, right, with a light gray brush. Now that I've done all of those operations, obviously there's going to be more drawing code here. Now that I've done more of that drawing code, I want to say, oh, I want to take my bitmap that I'm drawing onto, because when you draw onto a DC with a bitmap selected into it, you are drawing onto the bitmap. I want to now draw that bitmap onto that edge DC that represents the DC for the window with the size of its client area. So I want to now draw that and stretch it over that client area to say, hey, it doesn't matter what size of my bitmap thing, I want to stretch it over the size of the window. Before we do that, I want to just say rect dot right equals rect dot left plus max width and rect dot right. Rect dot right equals rect arrow right equals rect arrow left plus the maximum of either the width or the rect arrow right. And this basically ensures that my bitmap doesn't go smaller than what I'm trying to draw on, and otherwise it just completely stuffs up this calculation, because we're not doing the calculation for width and height again, for paddles and all that kind of garbage. We kind of just want to say, like, you can go bigger, but you can't go smaller than your initial size. So I just want to put this thing in here. It's the same for rect bottom equals rect top plus the maximum of the height and rect bottom. Yes. So we just alter this rectangle thing. I should make a copy of it. Actually, let's just do rect rc equals star rect. That makes a copy of it, right? Oh shoot, that makes a copy. It references it and copies it over. So now you can do rc dot. I think I like that, rc dot. So now you're working on a copy, you're not working on the original rectangle, because what if someone was using that rectangle outside and doing some important calculation with it? It would be rude to just like modify that rectangle out under them, right? So it just makes sense to make a copy, dereferences it, and then copies it value by value into this rectangle, because a rect is a simple structure. It doesn't have it doesn't have move semantics, it just has copy semantics, so this is an actual copy. So now I do the little calculation here based on width and height, and now I got my rect, and I fill DC and I fill rect. But now more drawing code here, and then blit. This blit thing is there's this thing called blit, This is actually a bit block transfer. It's basically saying there's a section of memory, a chunk of memory filled with these device dependent bits, which is also another way of saying here's a device dependent bitmap, and I'd like to transfer this block of bits from this one handle to a device context onto another handle to a device context. So you blit these bits. And blit is just block transfer. You block transfer these bits from one HDC onto another. It's just, but I don't want a bit blit because a bit blit doesn't have stretching semantics. I actually want this thing called stretch blit, right? So what that does is does internal scaling, so that you pass in a source rectangle and a destination width and height, and it does the scaling for you. You can select the stretch mode to be color on color, which basically just duplicates color, or you could set the stretch split mode to be halftone, which does an averaging of two colors. So if you've got a red and a blue, it will average those out and do the halftone of them. But I want to set the stretch split mode on which DC though? The HDC, right? The target DC. I want to set its stretch split mode to be color on color. How do you define it? Color on color. There we go. Set stretch split mode color on color, so that it basically just duplicates the color, so it gets a clean stretch, because our colors are all going to be so unique that we don't care about halftones. We don't want anti-aliasing per se. We're just drawing rectangles, so we just want to draw standard. If the rectangle is 5 pixels, so I draw 5 pixels in this color, just make nice solid colors. So then we stretch split, and let's go look at the stretch split onto the destination DC, which is this handle to the device context on the window. The X test is so it's going to be 0 0, right? The width of the destination is going to be rect right minus rect left, because it's the window, you can resize it. The height of the destination similarly is going to be rect bottom minus rect top. Let's just fix that dereference there. The HDC source now is our DC, which contains our bitmap. So whatever's in the bitmap will be copied onto the window. The X source is always 0 0 because our bitmap starts at 0 0, and the width and height is going to just be width and height. And that's our DC. X source, Y source, width, height. Rest operation is source copy. So let's just do more drawing code here, dot dot dot, and then blit. So the dot 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 replaces whatever it's going to do. Let's check if that does what I think it does. It should do what I think it does. But basically we should now have a window which you can fiddle with the size of the. There we go. There we go. It just neatly stretches it out for you. So there's obviously something wrong here. I think that color on color doesn't actually do what I think it does. Let's just check it. Win32 stretch split. Set stretch split mode function. Let's just see. I honestly don't think it does it in the specified device context. Black and white does and color on color deletes pixels. Oh, what does halftone do? Oh, that's unfortunate. What is the default? So basically what they're saying is that this thing that I thought does the color on color, alongside the explanation I gave for the thing that I thought does color on color, is actually not right. which makes me sad, Panda. I thought it was going to do the thing. Why is it not doing the thing? So what is the default? The default is still deleting pixels. Stretch and scans, same as black and white. I'm so upset. So basically what they're saying is, if you set the stretch split mode, not only do you have to set it on there, you have to set it to some like valid value. Let's try that. It should work now. Kind of upset. Also, does source copy do what I think it does? Nope, doesn't do what I think it does. And it also, I don't know if you see this, but there's a huge issue here. Source paint. You know what's gonna happen? Eventually, we're just gonna go read the documentation for how to do stretch split. Because I tried the only two like raster operations I remember. Oh, so check what paint does. That's interesting. So source copy is definitely the one, but the stretch split mode, I just want to get the stretch split mode. Oh, halftone produces higher quality images. Does this mean it's always been halftone and I just never paid attention? That's sad. Which DC do you set it in? See, these are the interesting questions you need to ask. If we don't see a change and we have halftone specified, then we know that the device context we've set it in is not the correct one. I am convinced I used to use color on color. Like, I can't think of any reason why it wouldn't be color on color. I'm unhappy with that in so many ways. Also, they were talking about set brush org x, like. So I filled this thing. What if, oh, put onto HTC 00 right, unrestrict. Actually, no. Put onto HTC 00 with height DC00 source copy. Return. I am sincerely convinced, like sincerely, that it must be wrong already. Yep, there we go. It is wrong already. You can actually see that pattern in there. That is not correct. So why is it not correct? Full rect onto DC black brush. Full rect onto DC light gray brush. Split. Exactly what we have, and that's already wrong. So what's wrong here? You get the DC of the window, create a compatible DC, create a compatible bitmap, release the DC, and then select it into this. Select into DCP, and then here you select old bitmap back, delete DC. Could it be that we are trying to construct that thing? No, we've constructed that thing after we've done show window, update window, right? Yeah, show window, update window. We are constructing that thing long after we've done show window, update window, so that should work. So we get this thing, and then we set the timer to this global window thing, which is set in the GHWin. Yes. You say here's my paint stuff, here's my on timer, and my on timer, all my on timer does is it says get me the client rect for this thing. Get me the DC and release the DC. There's nothing in here that indicates that it would fail. Let's just eyeball this. Yeah, set brush or X HTC 00. I did stretch split the other day. Stretch split was working fine for me. Like suddenly stretch split doesn't work. Oh, let's see. Stretch split. Split. No. Win3 to full rate. Hatch pattern. This is kind of what we're getting, right? So we want solid brush. Is get stock object black brush getting me something funny? Get stock object black brush. I'm convinced that black brush is just a black brush, a solid black brush. Oh, use the dark gray brush, and light gray brush stock objects only in windows with the CSH redraw and V redraw style. Using a gray stock brush in any other windows, blah blah blah, and cannot be adjusted. So this light gray, and dark gray cannot be used anywhere else unless you've got CSH redraw and CS. It's in there. Let's just try something silly. Fill this rectangle with black and then fill this rectangle on DC or with a white brush and then source copy that. I want to see if I need to set brush org X or if that gotcha that they mentioned there is actually gotchaing me. Could it be the gotcha they mentioned got me? Which DC would you set this on? Does it matter? Isn't it default often? Full DC, blah blah, stretch HTC, source copy. Okay, so the gotcha is that there's some classes of brushes, some colors of brushes. Yep, there we go. There's some colors of brushes that cannot be used. And the reason my stretch split used to work is because I was creating a brush. I was creating a blue or red or whatever brush I was drawing with. So some classes of brushes cannot be used without doing set brush origin X. Mind blasted. I think this is a great place to stop. I'm not happy with this flipping. You can see this thing it's doing. It's like a little dancey thing it's doing. I'm assuming it's because of floating point precision is not right. I also see this 4.2. I want to change this paddle height to like 2.1. It's because that blocky chunky paddle doesn't look right to me. When we did in JavaScript we had a pretty paddle all happy. There we go. There's my pretty paddle. Here's my pretty paddle. Here's my pretty paddle. Okay, so I'm happy with this. We've now got a drawing loop and we've got a double buffered drawing surface that independently of whatever you this is exactly the same as we had with the canvas, where we said the internal canvas buffer is some width and height and then stretch it onto whatever the window width and height is. We now have it in a much neater way. I think next time we'll explore how the heck do we make it so Oh, Windows is just smart enough to handle that. How do you make it so you can't resize this window down below a certain size? I think that's going to be beneficial. And then we'll start handling keyboard input or mouse input to move the paddle. I think I'm happy with that. We'll start replicating all that logic we had previously, because we now have the same platform to work on. We have a rendering loop, we have a double buffer, and we have a fixed simulation width and height, fixed simulation area. We now have a Cartesian coordinate that starts in the top left here and goes across till 320 and goes down till 240, and we're successfully stretching it over the window every 1/30th of a second to get us a 30 fps drawing loop. And this is auto scaling and translation, all that crap's handled automatically for us by just saying draw this bitmap at the top left corner, in the top left corner of the client area, and the width and the height covering whatever's there of the client area. And the internal bitmap itself is 320 by 240, so whatever you stretch it to, it looks however it looks, right? So this is nice. This is basically what we had in JavaScript. It was a lot more work, but it's worth it because now we've got something stable. So from here on out, we're just going to animate the same thing that we had. I think maybe we're going to create a couple of brushes. I feel like we need brushes. I feel like we need text handling. I feel like I want to create a structure for paddle and ball, but I'm happy with this. As always, I'll put the jet up. I'll take this garbage out. I'm not happy with this garbage thing, but there's going to be more drawing code that goes there, but I'm happy with this the way it is right now. This gives us a double buffered rectangle on a double buffered screen, and I'm happy with that. Not how, oh, we edited resources, we did a bunch of garbage, did like a little bunch of garbage, and we can actually exit this program, so that's fine. The debugger also responds, so I'm happy with that. Thank you very much. My name is Shade, and welcome to my I can't say that. Thank you for attending my I cannot say that talk. It's been fun having you, and again I apologize, I lost my previous audio. Damn, make it up to you. I've got you extra audio. All right, cheers.